Okay, so we've been doing integrals for a while. So today we're going to be talking about area between curves. So we've done area under the curve, which is basically the area between a function and the x-axis. But now we're going to talk about how do I find the area between two functions. Okay, so how can we find these areas? Okay, this area enclosed right here between these two curves. Now we could split it up into a bunch of little areas, sections using integration. For instance, this linear function. If I do the area or the integral from here to here, it's going to give me this area, okay? And then from here to here, it's going to give me all of that area, all of this area right here, okay? But I don't want all of that area. Same thing here. If I do the area under the curve for this one, from here to here, it's going to give me all of this area, okay? And then it'll give me this area here, and then this area here. So basically what I'd have to do is I'd have to find the area from here to here, all of it, and then subtract out this part right here, okay? So I'd have to find all of it and then subtract out that area, then add this part and this part, but then subtract out this part. Okay, so it would just be a mess. Trying to sit here and do these separate integrals, it would take me forever. Okay, so what we do is we think of it kind of like we did when we started area. So we consider this one very thin strip. Okay, this has an area. It's basically a rectangle. Okay, now the length of the strip is the distance from here, right here, to right here. It's y1 minus y2. So if I pick any spot here, it's still going to be y1 minus y2. It's this distance. Okay? So that's my length. So plugging in my functions, I can plug it in and look like this. So this is the length. So I'm trying to find area, right? So area is length times width. So since the width of the strip is a very small change in x, we could assume we could just call it dx, because that's what we know dx is. It's the differential x, a small change in x. So that means my length times width basically is going to be y1 minus y2 times dx. Okay? So, but that's only the area of one of those. Okay? And we don't want just the area of one of those, we want the area of all of them. Right? Because we want to find the total area of this thing. God, I wish we had a function that adds up a bunch of stuff for us. Oh, wait. The integral does that for us. So if we actually set up our integral from beginning to end, so we're saying, hey, I want you to find the area from here, -1, all the way to here at 2. And I want you to add up all those little strips that we just created that have a length of this. This is your length times width. And you're adding up all of these areas that this function will do it for us. Okay? So that's basically how area between two curves works. And then the antiderivative, and that is just a definite integral. We've done that a million times. Okay? The hardest part is figuring out which function is going to be the top part of our strip and the bottom part of our strip. Okay? And then after that, we just do our antiderivative, plug in our top limit minus our bottom limit, simplify, and we get our area, which was 27/6. Okay? So the hardest part of this is basically figuring out our equation. Okay, so we have basically two equations. Okay, one area equation when our strip is vertical, okay, or perpendicular to the x-axis, and that's this one. This is the function on top minus the function on bottom. Okay? If you're using horizontal strips, it's right minus left. Okay? So these are our two equations. So if we have, basically, if we have two functions here and our strips are vertical like this, that's because this change right here is my dx. Versus horizontal strips, that means this is my strip and this is my small change in y. So it just depends on which way we're going to be going. And it does sometimes matter. It makes it easier going one way versus the other. Okay? So for instance, this problem here. Okay? Again, I want to find this enclosed area. Okay, but if I try vertical strips, we're going to have to split this up in more than one part. Because at the first part here, from here to here, this is my top and this is my bottom. But then when I get to here, it switches functions, so I'd have to set up two different integrals to do this. And that's just too much work. Okay, when I can just use one integral to set it up. So what we're going to do is we're going to switch to one integral, okay, by doing it horizontally. And this is what you're going to have to decide on how you're going to do this, because you could very well have done the first one and done it that way with two different integrals, or you could do it this way. Does it make a difference? No. Will you find the same area? Absolutely. But one way is going to be easier and less work, and one way is going to be harder and more work. Okay? But you noticed this one, if you actually put any strip in here, it'll always hit the same two functions the same way. Okay? So instead of doing it top minus bottom, we're going to do it right minus left. Okay? And the one on the right, of course, is the linear function. But the only difference is that we have to get our function in terms of x. Because in this one, our functions are in terms of x. In this one, since it's dy, we got to get x in terms of y. So that's the only thing that tends to make it more difficult. But in this example, we're taking that square root, which taking the antiderivative of that one is a little bit more difficult because we're dealing fraction powers, and changing it to a whole number, making it a whole lot easier on us. Okay? And then, of course, basically the same thing we did in the last one. We use our equation, and in this case, you can see it's right minus left inside, and then you simplify, antiderivative, plug in the top limit, and you get your answer. Okay? Now, your code is MRKR0KS. That's your code to move on from the notes section. All right, so general strategy area between curves. Step 1, if you can, sketch the curves. Okay? Step 2, decide on vertical or horizontal strips. Okay? Pick whichever is easier to write formulas for the length of the strip, or whichever will let you integrate the fewest times. Okay, there's going to be some times where it doesn't matter which way you do it, left or right or up and down. It's going to be more than one integral. Okay, but if you can figure out a way to do it in the least amount of steps, that would be the ideal. Number 3, write an expression for the area of the strip. So if it's doing vertical ones, you're doing the top minus bottom. If it's horizontal ones, you're doing right minus left. Okay, make sure your functions are in the term of the correct variable. 4, find the limits of integration. So if the integral is in terms of dx, your limits should be x values. If it's in terms of dy, then your limits are y values. And that's the number one mistake my students make. And then, of course, integrate and find the area. Okay? And that's it. Basically, we're just doing definite integrals. We're adding one more step.